electronic cigarettes are very similar to like the fog machines you might find in nightclubs. So I thought it'd be quite interesting to know, to get the answer, how does it create that fog in the air? And if you go onto the electronic cigarette forums and you look about, or you even ask online, nobody ever gives you a straight answer. The furthest it gets is the liquid goes up into the atomizer and then gets atomized. They never actually tell you how it gets atomized. So let's work that out ourselves, shall we? So I'll just put these out of the way. I should mention that not the battery, but the atomizer and the 10 milliliter bottle of e-liquid with nicotine in it, which I'm not really keen on the nicotine, but I thought it was quite interesting that Poundland sells these items, £1 each. That's how far electronic cigarettes have come. So looking at the principle of the atomization itself, we have to actually start with real fog. So if you can imagine, and this is what this hard thing where I hate these images where they draw the picture of the eye and it's like, ugh. But imagine an eye looking at a tree, and here's a graphic representation of a tree, and if it's looking straight at the tree, it'll be a nice clear image of the tree. However, on a foggy day, you get that hazy effect that obscures the tree. And the reason for that is that air can absorb moisture, and it's called relative humidity. It depends on the temperature of the air, and warmer air can absorb more moisture than cold air. So what happens is warm air, say maybe 20 degrees centigrade, absorbs a lot of moisture, absorbs like 90–100% moisture, whatever, as much as it can absorb to the point of saturation. And then the temperature lowers, it goes down to 15 degrees centigrade, or 10, and suddenly the air can't hold that amount of moisture anymore. So what actually happens is the water starts coming out of the air and it forms little droplets. And these little droplets have a different refractive index to air. The light going through them, if they had the same refractive index as air, they'd just be invisible. But because they've got a different refractive index, the way they bend light, instead of the light coming from the tree straight back to the eye, it's now hitting these, and it's getting branched off in different directions. It's like basically lots of little lenses. And the way to emulate this is, if I get these marbles, I got the clearest marbles I could get. I couldn't get absolutely clear marbles, but here's glass balls representing the little water droplets in the air. There's the tree. You can see the tree. Suddenly the tree is obscured by these little balls because they're just acting like lenses and deflecting the water, deflecting the light. Now, this is also a point where I can bring in this huge one that came with these. This is called, in Glasgow, this is traditionally called a jory. It's a large glass marble. And that is the birth of the phrase, "Help my Bob, my jory's gone doon the stank," which translates to, "Oh my goodness, my largest prized glass marble has gone down the drain and I'm not getting it back again." I just thought I'd mention that. It's a little cultural thing. So this is the principle of fog. It's basically tiny little droplets of liquid in the air creating that sort of lensing effect. And you can see this. If you open your freezer and the warm room air goes in with moisture in it, it instantly gets chilled in the freezer and suddenly you get that rolling fog effect. That is the moisture coming out of the air that was in the room. So we can emulate this. And the best way to create fog, the easiest way to create fog that's not involving water vapor, you can do it with the water vapor, but it doesn't last too long and it's a bit, it's a bit unpredictable. So what they do is, the most common ways of doing it are creating a fog of tiny little, the same little lensing effect, but with glycols or oils. And they all use the same principle. If you have a bubble, if you blow a bubble, and then the bubble bursts, that surface tension that's holding all that liquid together, it doesn't just, it's not like a balloon that it just folds round into one bit of rubber again. It usually doesn't. Usually it splits into separate bits. When a bubble bursts, you actually get lots of tiny little droplets of liquid. If you actually see a bubble burst in bright light, you'll see it turns into this cloud of droplets. And that's the principle of creating a fog by chemical means. And one of the easiest ways of doing that is an oil cracker. And an oil cracker is very simple. It's a tank. It's got a really fine mineral oil in it. Mineral oil. And it's either got, gas or air inlet, sometimes carbon dioxide, sometimes air, and it could be a really sharp point, it could be a tiny little nozzle, or it could be an air stone of just compressed sort of grit to create lots of paths of the air, and these stream out little bubbles in a large volume. And when these bubbles get to the top of the oil and they burst, they turn into tiny little droplets of oil. It shatters into those little droplets that, you know, are caused by the breaking of the surface. And in the case of an oil cracker, there's an airflow across the top of it, and there's also the airflow coming through from the jets, and it's all balanced so that the largest droplets will just go back down by gravity. They'll go back into the oil bath, but the tiniest little droplets will get carried out into the room and they create the nice haze in the air. And so that's the principle of creating it with, well, that's the simplest way of creating it, is just blowing compressed air through oil. However, electronic cigarettes and smoke machines use a different technique. They rely on the fact that glycerol, otherwise known as glycerine, which is a food grade, glycerin or glycerine, it's a food grade alcohol, or sometimes in the case of electronic cigarettes they use propylene glycol. Now, I've published videos showing how you can make your own e-liquid, super high dense e-liquid, by basically getting glycerine or glycerol and adding a small amount of water. And you'd only need to add enough just to make it actually wick up, that wick reliably. Well, flow in, because glycerine is very thick and sticky. This is glycerine here, and this is propylene glycol. I'll come back to those in a moment. But it's very thick and sticky, and on its own it wouldn't wick up very well. So there's a delicate balance. Quite often, proper e-liquid like this probably contains, I'm not sure, does it say? Oh, hold on, it's got ingredients. Let's read the ingredients. Let's get the magnifying glass out, read the ingredients. It says food flavouring, aroma, propylene glycol, vegetable glycerine and nicotine, which is pretty much what you find in e-liquid. And generally speaking, the propylene glycol is added just to water it down, but the easiest thing to find for making your own e-liquid, and if you just give me a second, I'm just going to go and grab a bottle of it. Is glycerin or glycerine. This one comes from Boots in the UK. It's a chain of chemists, and it's quite cheap. It's about £1.50 or something for this bottle, and this makes tons of liquid. But anyway, in the past I've said you can just make it with the glycerine on its own. If you just want clouds of smoke and you don't want the nicotine, you can add flavouring if you want. You don't need the flavouring, but you have to add a bit of water to water it down. And people have said, oh no, you can't add water. Breathing water vapour is really dangerous. And it's not. Breathing water vapour is the equivalent of breathing steam. If breathing water vapour is dangerous, you go into a sauna and you die. If you were drinking a cup of coffee and steam came off it, you would die. It's not dangerous. And there's absolutely no choice about having water vapour coming out, because that is the principle. I've actually spilt some of that. That's annoying, because that's going to skew the results a little bit. Anyway, have I got a crack in that or something? Why is it leaking? But anyway, the glycols have water in them. You've no choice about that. If I unscrew the lid of this bottle and just left it sitting out, it would get heavier. It would absorb water out of the air, because glycols are hygroscopic. They absorb water from the air. And to prove that, here's a set of drug scales. Thank you, drug dealers, for making these cheap, high accuracy scales available to electronic experimenters. So this is glycerine, and I put these both out 2 days ago. I'm a bit annoyed that I've spilt that one slightly. That's going to skew the results, hopefully not too much. And I noted when I poured them out the weight, and in this one I've written 28.3, so this is 28.3 grams. 2 days later, it's now 30 grams. So it's gained approximately 1.7 grams of weight. It's absorbed 1.7 grams of water out there, which is roughly almost, that's about 6 or 7% it's absorbed out there of its own weight. The propylene glycol, this started off weighing 21.65 grams. it's now weighing 24.19 plus whatever I've just spilt. So it's also absorbed a significant amount of moisture out there. And the longer I leave these out, the heavier they'll get, because they're actually, right now, they're absorbing water from the air. And this is important because this is how e-liquid works, the whole concept of the creating the clouds. You see, when you heat up these liquids, the water will boil first. Now, in the case of glycerol, the boiling point of glycerol is 290 degrees centigrade. The boiling point of propylene glycol is 188 degrees centigrade, and I'm cheating, I'm reading off a piece of paper. Hold on, I'll just bring it in so you can see. Triethylene glycol is 285 degrees centigrade, and of course water is 100 degrees centigrade. So if you mix the two together, if I had a hot surface, hot, sizzle, 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 and I put a droplet of e-liquid onto that surface, then it would immediately boil. But the first component of the e-liquid that would boil is the moisture that was in it. The water would boil, and that would basically create lots of bubbles on the surface, because the glycol wouldn't be boiling, it would be the water in it. And these bubbles would then be bursting, and that's what creates those droplets of vapour. And in the case of an electronic cigarette, the way it's doing that is it's got the strands of the wick, and it's got a coiled heat element around it, and that's heating. The liquid's wicking up the wick and getting taken into the heat element. It's getting boiled, and those bubbles will form all over the surface of that and then burst. And as you're drawing the air through, you're drawing through those tiny little microscopic spheres, those little beads, those little lenses of glycol, and that's what creates the fog in the air. In the case of the fog machines in nightclubs, it's slightly different. They tend to have a much higher ratio of water to the glycol. Quite often the range of about 30% glycol to 70% water. And what they do is they've got a heater block, and the heater block could be a sandwich of metal plates. It could be 3 aluminium plates all sandwiched together with bolts, with fluffy fiberglass all around it for thermal insulation. And then the top plate, it could have a big heat element winding backwards and forwards like that to make it hot. And in the bottom plate, it might have, say for instance, a little copper tube going in and just winding backwards and forwards in there. The copper tube ones is traditionally how it was done. And what happens is the liquid gets, the mixture of the glycol and the water gets squirted in at a pressure from a wee solenoid pump into this copper pipe, and this block is heated up to a very specific temperature. There's a wide tolerance to the temperature, it's not that bad, as long as it's sort of the point it's going to basically evaporate all the water without burning the glycol. That's the main thing. And that causes as the liquid travels through, it immediately explosively atomizes, and because of the large length it has to go through, it makes sure that most of it is atomized, and it comes out as that big plume of steam out the other end. Let me demonstrate with this cute little smoke machine. Yeah, well, that's the place well and truly fogged now. So what we're seeing there, this clouding fog that's floating about, is actually lots of tiny lenses. That's those little glycol lenses again that's creating that optical effect. And I'm looking at this right now with LED lights up here, and it's creating a very visual optical effect. It's creating a sort of silk-like sort of liquidy lens effect. It's quite impressive actually, it's quite neat because there's such sharp points of light. In the case of cheaper smoke machines like your little Antares smoke machines, your little disco-y toy ones that you get out of places like Maplin or Walmart or whatever, they do cut down, they make the heating block much simpler, and it tends to be a block of aluminium, and it's got a core drilled through it, a hole drilled through it. The heat element might be pressed into the end in a channel, or it might just be sat on the surface, and then they put a sort of almost like a screw thread through the middle and press it through so that it kind of fits quite snugly to that. And when they put the liquid in, it has to find its way through that spiral. It's a convoluted route while it's being heated before it comes out as a steam. It's not as efficient as it's a lot cheaper to make and simpler than the copper tube one, but it's not as efficient. It doesn't create as good a fog, and also you tend, with the shorter path, it's more likely to blow out liquid. And this is the case if you got too much water in the water to glycol ratio, you can end up, when it's pumped in, you end up with too much, too much pressure. It tends to blow, it tends to sputter and blow out droplets of liquid out the end. It's just, sometimes you need a fairly accurate balance with smoke machines. So that's the principle of the atomization. Now, one of the issues with, normally if you've just got normal e-liquid and you've just got a normal vaporizer, that's no problem. There's no real issue with that. The problems that are widely touted by the tobacco industry, because they've got vested interests, is that these things put out acrylins, or acrylins, not 100% sure the pronunciation. But that happens with the cloud chasers because they're using these super high-powered, big battery packs and tiny resistive elements that really, they're looking for huge clouds of vapour. And what they're actually doing is they're burning the glycerine, and that's what's the problem. It gives that, when you burn glycerine, if you ever get one of these and you inhale through it and it just tastes all burnt and horrible, then that's what you're getting. The actual glycerine is burning on the heating element. It's not the correct ratio, or the elements just clogged up. It's not working well. So that's the main hazard with that's the primary hazard with electronic smoking. And with typical just ordinary vaporizers like these, that's not a huge issue. It rarely happens. Now, moving on to other fogs. There are other ways of creating lots of water droplets in the air, and they tend to be used by the special effect industry. Now, you also get the ultrasonic foggers, the ones where it's the bowl of water and it's got the little metal block inside with the piezoelectric disc, and it creates high energy ultrasonic sound that makes all the water spray into the air. That also shatters the water into the tiny droplets. But there's another way of doing it, and it's done by a company called e-cig. e-cig is one of the biggest names in sort of showbiz industry, the theme parks and so on. And what they do is they take really purified tap water, they filter it because they have to for this application, they pressurise it up to thousands of pounds a square inch, and then basically just super tight nozzles, they blow it through like basically misters, but really done on a super microscopic scale. And you'll see this if you go to some theme parks for theming. You'll see the sort of clouds continually of the vapour just sort of clouding round certain effects in the theme parks. That's probably just water, because let's face it, the consumables are very cheap. It's just water. And they require a little bit of maintenance. You have to clean the filters, you have to change the jets every so often. But on the whole, it's a very simple way of creating that sort of clouds of fog in the air. Also nice and cooling effect. It's a good effect. Me also put these systems into hydroponic applications, for misting plants and changing the humidity of places. It's not just the entertainment industry. So that's e-cig, ultrasonic. Then there's carbon dioxide and dry ice. Dry ice and carbon dioxide work the same way. They're basic cryogenic substances. They're both carbon dioxide. Dry ice is a solid block version of carbon dioxide, and in the case of like the big theatre foggers where they get the rolling fog over the stage, that's basically a big tank of water with a heating element in it, and then they lower a cage like a chip fryer, a potato fry fryer filled with the dry ice. They lower it in, and there's a lid, and then there's a big pipe out, and the carbon dioxide immediately, when it goes into the hot water, immediately turns into gas, and that carries out a fine vapour of that really heavy low temperature fog that then rolls across the stage. In the case of the carbon dioxide jets, they're commonly used in rock bands, concerts, stages, to create that plume of fog that goes up and then disappears instantly. It really dissipates very quickly. All they're doing, they've got the conical jet, they've got a liquid feed of CO2 from a tank, and then they've got a cryogenic valve. It's important to use a cryogenic valve that's rated for those temperatures. It won't freeze up and stay open. And that's ultimately it. It's just basically when they want the plume of fog, they energise the valve and it sprays the liquid CO2 out, and it instantly creates this fog in the air. Other more exotic methods of creating a haze in the air are haze pots. Haze pots are not very common these days. I've not seen one in a long time. But basically speaking, the traditional haze pot would have been a conical ceramic pot with a physical heating element actually wound round it, all exposed, and it went into an Edison screw lamp holder. Not safe by modern standards. Your only place you're likely to find these now is on eBay, just as a sort of novelty. But they were basically exposed, they'd glow red hot, and this was a ceramic pot, and into that you'd put what's called salammoniac. Otherwise, the salammoniac is a sort of stage name. It's like ammonium chloride is the official name for it. Ammonium chloride has lots of uses. One of them is the electrolyte in Leclanché cells. That's something you could look up. Leclanché cell, one of the first batteries. But when you put it into this pot as a dry powder, and all these were ultra low maintenance, they lasted for ages. You just basically checked it had loads of powder in it, turned it on, and it would separate, the heat would separate that into two different sort of chemicals that would then recombine, and this doesn't sound healthy, does it, into a solid chemical particulate in the air. And it just created this fine particulate, this really fine, ultra-fine dust-like smoke in the air that had very good optical qualities, but was, to some people, an irritant. This predates fog machines and smoke machines. The other way you can create the particulate smoke is with smoke cookies. Cookies are usually about that size and shape, and you light them, and they're basically a pyrotechnic compound, and they contain quite often dye, red, green, blue, yellow, black, whatever you want, but it really is, it creates the smoke, it creates the particulate smoke, and the colour is actually dye in the air. You know, it's physically particles of coloured material floating about in the air. It stains everything. In the theatre industry, if they use it on a stage and someone gets too close, it'll leave a big skid mark up their clothing if they got in the vicinity of the smoke. It's just basically airborne dye. It's not really suitable for breathing in. So, other things that are worth discussing. The smoke machine manufacturers in the early days, despite the fact that the fluids were very simple, they contained a glycol, or in the very earliest days, and still now for haze machines, they use glycerin, because it's a very simple and very safe material when used correctly. They used to come out with all this scaremongering that it was top secret ingredients, and you'd be paying a fortune for this liquid that was only for that machine. In reality, most of the machines, most standard fog machines that use the heating element in the block can use just about any liquid. You get generic liquids that are suitable for use. The main requirement is that they're made with distilled water, very pure water, and good quality sort of medical grade glycols. You don't want just generic random industrial chemicals with lots of impurities, because you just don't know what you're getting into the air. And one of the most common failure modes of smoke machines is blockage, heater blockage. It's that little pipe that snakes through the heating element does fur up, particularly if the wrong cheap smoke fluid's used, or you try and make your own with just tap water, hard tap water with lots of minerals in it, and mixing it with glycols. So, it helps. If you have a smoke machine, it's worth noting that you can clean them by flushing them through every so often outdoors with the white vinegar and water, and that just basically helps defur them. It descales them inside, but don't breathe in the vinegar vapour. It's just horrific. Don't do it indoors. Your whole house will smell like a chip shop exploded. It's not a good thing. Now, there is one other fogger that's worth mentioning, but you guys, seriously, I say this honestly, you guys cannot afford one of these because the running costs are horrendous. But these are liquid nitrogen foggers, two of them. The location is Cinemagique in Paris, Disney Studios, Paris. And for an idea of scale, that's me standing between them, and I'm 6'4". These machines are huge, and the way they work is they have a control panel that meters water into these cylinders, and it's kept at a level where these heating elements, and there's just rows and rows of these elements, there's rows of heating elements on both sides, because it involves heating this water up to basically keeping it at boiling temperature and regular use, because this is a show that runs continually. So these heating elements heat the water up to boiling temperature, and then this pump down here pumps it up and sprays it into the chamber when on demand. And when it sprays it, it also pumps in liquid nitrogen. These are all cryogenically insulated tubes and feed and control systems. And it sprays the liquid nitrogen into the spray of boiling hot water and instantly creates massive plumes of smoke. And you can see one of the pipes going up here. The pipe's probably about 18 inches diameter. It's a massive pipe that goes up. In this case, it goes up to behind the screen and actually blows the smoke through the screen. But these machines you're only seeing half of it here because liquid nitrogen can't be stored. You can't just have a bottle of liquid nitrogen, sit it next to it. Liquid nitrogen can't even be stored conveniently in a tank like liquid carbon dioxide can. Liquid nitrogen would reach such a high pressure that it would be quite hard to contain it. So it gets stored in what are called dewars, which are vented tanks. And they're thermal insulated, and as the liquid nitrogen evaporates, it has a self-cooling effect due to the evaporation. So, once they're filled with the liquid nitrogen, they'll vent off occasionally outside, but they basically keep themselves cool. That's how it's stored, but they still do require to be filled from a cryogenic lorry every so often, quite regularly in fact. But that's piped in through cryogenically rated pipework with super thermal insulation on it to actually keep it all in its stable form and stop it venting, gassing off in the process. And then it's fed through cryogenic valves, really complex, super complex. In this case, Disney uses it because it's a great way of creating massive quantities of white fog in great volume without too much chemical involvement. Theatres, if you ran liquid glycol foggers or oil foggers all the time, they'd become soaked with the oils and glycols. But in this case, it's a very clean system, and as opposed to carbon dioxide, which is the major oxygen depletion thing, the nitrogen is a major component of air anyway, so it's less hazardous, but it still requires emergency dump systems, it still requires safety systems, evacuation systems, oxygen monitoring systems, so that, if the level of oxygen in the air gets depleted, it will set off an alarm and everybody gets evacuated. This is not for the likes of us. This is just the likes of Disney. So, So that sums up most of the systems for creating fog, including the electronic cigarettes. So, interesting subject, but it's actually fairly complex.